Hi, my name is Mr. Evangelista, and welcome to another episode of Evangelist Science. Today we're going to be talking about Lewis dot structures. Before we talk about Lewis dot structures, we've got to talk about valence electrons, which is a bit of a review for us. But valence electrons are electrons in the outer shell. So if we look here, the electrons in red are the outermost electrons, and those are our valence electrons. You can see here that chlorine has a ton of electrons, but only has 7 valence electrons because only 7 of those electrons are in the outer shell. Now, potassium has a ton of electrons, but only 1 valence electron. That's because only 1 is in the outermost shell. Now, if we look at the periodic table and we count left to right, ignoring the transition metals, we can see that we can pretty much count the number of valence electrons just by going 1 through 8. Group 1 has 1, group 2 has 2, and if we move over here, this is 3, 4, 5, 6, 7, 8. Notice the exception is that helium would have 2. Now, these electrons are important because these are the electrons that are available for bonding. Only these electrons are the ones that can bond with other atoms. So, if we look at hydrogen, hydrogen is right here. It's got 1 valence electron. Okay. Nitrogen is right here, and so it would have 5 valence electrons. And then helium is right here at the end, and so it has 8 valence electrons. Now, I'd like you to do these on your own. Figure out how many valence electrons these atoms have. Pause the video and work on this, and then we'll go over the answers. Alright, hopefully you pause the video. And so let's go over this. Hydrogen right here has 1 valence electron. Helium is over here, so it would have 2. Carbon's right here, so it would have 4. Nitrogen's right here next to it, so it's 5. Oxygen's right here, so it's 6. Phosphorus is right here, so it would have 5. Sulfur is right here, so it would have 6. Fluorine right here, so it has 7. Sodium is over here, so it's 1, and neon's over here, so it has 8. Perfect. Now, why do we care about valence electrons? Well, because they lead into something called the octet rule, which is the tendency of an atom to have valence electrons, 8 valence electrons. Notice hydrogen and helium only want 2 valence electrons, so it's a little exception, but most of them are going to want 8. And the reason they want 8 is because 8 electrons equals stable. Noble gases already have 8, and so they're very stable. They don't want to react with anybody. But the ones that don't have 8 need to somehow get to 8. And so that they will either share or donate their electrons to become more stable. So let's draw Lewis dot diagrams, and these represent the valence electrons. So before, remember, we would draw the entire atom. We would draw the 1s2, the 2s2, the 2p6, the 3s2, and so on and so forth. Well, since the valence electrons are the only electrons that are going to be bonding, those are the only ones we really need to draw. And so the way we draw that is, if hydrogen is 1 valence electron, I just put 1 little dot around the symbol. Carbon would have 4. So the way I draw this is I put 1 dot on each side of carbon, like that. Now, nitrogen has 5, and so once we put the 4 dots and we still need to add more, then we can start doubling up. And so I can double up on one side. There's nitrogen with 5 valence electrons. Oxygen has 6, so again I put 1 on each side. And then once I have 1 on each side, I can start doubling them up. And so this is what oxygen looks like. Chlorine needs 7, so I go 1, 2, 3, 4, 1 on each side. And after I put 1 on each side, I can start doubling them up. And this is chlorine. Okay, a little technical error there, but I would like you to practice now. Go and pause the video and try to draw the Lewis dot structures for these atoms. Alright, hopefully you pause the video and we're going to go over the answers. Magnesium, 2 valence electrons, so it looks like this. Lithium, 1 valence electron, so just 1 dot. Fluorine has 7 valence electrons, so it's going to have 7 dots around it, noticing that we can't have more than 2 dots on one side. Phosphorus is 5, so it have 3 single dots and then 1 doubled up dot. Sulfur is 6, and so it looks like this. Now, this periodic table here just shows elements 1 to 20 and what their valence electrons, what their Lewis dot structure looks like. Notice everything in group 1 has, look at that, 1 valence electron. Everything in group 2, 2. And then here we have 3, 4, 5, 6, 7, and 8, with the exception of helium, which has 2. So what if we need to draw Lewis structures of molecular compounds, meaning more than one atom that are covalently bonding together? So electrons can be shared to reach an octet. So let's draw the Lewis structure for hydrogen, H2. So that means we need 2 of these hydrogens, okay? Now hydrogen, in order to reach an octet, would want 2 electrons. Now this hydrogen has 1 and this hydrogen has 1, and so what these hydrogens are going to do is like, look, we both need 2, why don't we share? And what they do is they form a covalent bond when they share these electrons. And the way we show that is we draw a little line. So this line represents 2 electrons, one from this hydrogen and one from here. So this is actually 2 electrons. So they form what's called a single covalent bond. What about for if we have oxygen, O2? Here's oxygen. There's the Lewis dot structure. And this oxygen is 6, this oxygen is 6. And so they both want to get to 8. And so what they can do is they can both share not 1, but 2 electrons. So these 2 electrons are going to be shared, and then these 2 electrons are going to be shared. And they can form what's called a double bond. So notice that this electron and this electron are represented by this line, and then this electron and this electron are represented by this line. So they form a double bond. Then the other electrons are still, we still draw those at the end. What about N2? So let's see. Nitrogen looks like this, and it needs 3 more electrons on each nitrogen. And so what the nitrogen do is they decide to share this one with this one, this one with this one, and this one with this one. And so what they form is a triple covalent bond. Let's do a couple more examples. What about H2O? Well, let's draw the dot structures. Here's hydrogen, here's another hydrogen, and here's an oxygen. Now, how do you think this is going to work out? Well, it turns out this guy needs 8, and each of these guys need 2. And so these are going to be shared, and then these are going to be shared. And so we've got 2 single bonds, and remember, oxygen still keeps its lone pairs of electrons. One quick tip that we're going to add, if you ever have hydrogen, they're always going to go on the outside of the molecule. So let's take a look at CH4. We've got 4 hydrogens, and then we've got 1 carbon. Now, how do you think this is going to look? Well, we said that the hydrogens need to go on the outside, so that probably means that carbon's going to go in the middle. So these 2, carbon needs to get 8 to 8, hydrogen needs to get to 2. So we can share these electrons here, share these electrons, share these electrons, and share these electrons. So we get a structure that kind of looks like this. Oh, it's a little cut off there, but CH4 looks like this. Carbon single bonded to 4 different hydrogens. Oh, and then what happens, sorry, a little error there, but CO2, so the least electronegative goes in the center. So out of these molecules, that's going to be the furthest one from fluorine. Remember we learned about electronegativity? Fluorine is the most electronegative, so the further away if you are from fluorine, whichever atom is furthest away from fluorine is going to go in the center of the atom. So we've got carbon and oxygen. That means carbon is further away from fluorine than oxygen. That means carbon is going to go in the middle. And so how do we do this? Well, this oxygen needs 2 more, this oxygen needs 2 more, and the carbon needs 4 more. So we'll do a double bond with this oxygen and a double bond with this oxygen. Cool, so hopefully you've had enough examples and ready to do some practice. So go ahead and do these and then we'll go over the answers. Alright, let's go over these answers. HBr. HBr is going to look like this. Bromine needs 1 more because it's got 7 to get to 8. Hydrogen needs 1 more, and so there's a single bond between them. NH3, remember the hydrogens always go on the outside. Excuse me. And so NH3 would look like this. C2H4, hydrogens always go on the outside, and so it actually looks like this. Remember, carbon needs 4 electrons to share. Hydrogen needs 2. What about here? Carbon needs 4. Hydrogen needs to get to 1 more electron, right? So carbon needs to make 4 bonds. Hydrogen needs to make 1, and oxygen actually needs to make 2 because it's at 6 to get to 8. And so it looks like this. CH3Cl would look like this, and C3H8, lastly, would look like this.